this video, what I'll be discussing are some quantitative aspects of the kinetic molecular theory. We were introduced to it earlier, but when I talked about it, I basically described it in a qualitative way. In other words, there were no numbers attached, there was no measurements or anything like that involved. I just described what the kinetic molecular theory is all about. So, and again, well, not again, but let me just say this. So these equations I'm about to show you, to be perfectly honest, I won't be even required that you know them or know how to use them, but I'm going to use these just to explain some important aspects of the theory. So using the kinetic molecular theory, we can actually show that this equation here is true. The pressure of the gas will be equal to 1/3 times N over V. Now, N is the number of molecules, V would be the volume, M would be the mass of each molecule, and this here is a very important term called the U squared here, with a bar above it. That's called this average of the squares of the speeds of the molecules, right? So what that term means is, let me go back to my black ink here. So what that term means is that, okay, U squared bar is equal to the square of the speed of gas 1 plus the square of the speed of gas 2 plus the square of the speed of gas 3 all the way to this square of the speed of the nth gas, right? Gas molecule. All of this divided by the number of gas molecules. So basically, this term here is basically all this right here, right? And we can actually show that the pressure of a gas, the pressure exerted by the gas, is related to it according to this equation right here, all right? And that shows you some important things, especially in terms of confirming certain laws that we observe. For example, based on this equation here, we can see that there's an inverse relationship between the pressure of the gas and the volume of the gas, right? Which, of course, is what Boyle's law says. The pressure of a gas is inversely proportional to the volume. But there's some other relationships we can look at as well. For example, the pressure of the gas is directly proportional to the number of moles or the number of molecules of the gas, which is basically what Avogadro's law is saying, right? We can also see that the pressure of the gas is dependent on the mass of the gas particles. So what this suggests is that the heavier the particles of the gas molecules, or the heavier the particles, the greater the pressure that would be exerted by the gas. And then, of course, this term here is basically representing the average of the squares of the speeds of the molecules. So basically what this is saying is that the faster the molecules travel, then the greater will be the pressure of the gas, which makes sense because, of course, if the molecules travel faster, then they'll hit the walls of the container harder, and therefore that would be manifested with a greater pressure exerted by the gas particles, all right? So that's basically what that equation is telling us. And then based on that equation, we can derive this equation, which relates the kinetic energy of the particles or of a gas to a couple of terms, namely the temperature, the molar gas constant, and here we have Avogadro's number, right? Now, the molar gas constant and Avogadro's number is a constant. 3/2 is a constant. So pretty much what this is showing us is the relationship between the kinetic energy and the temperature. So we can simplify this equation into this right here. And basically what this is telling us is that the average kinetic energy of the molecules is directly proportional to the temperature of the gas. So basically the higher the temperature, the greater would be the kinetic energy, all right? So those are just some quantitative aspects of the kinetic molecular theory that I thought it was important for us to cover it. As I said before, you will not be using these equations in any questions that I will provide for you, but I thought it was important that, I show you these so that you have a clearer understanding of the kinetic molecular theory. Okay, so the next topic we're going to talk about in the next video deals with molecular speeds, all right? Until next time.